Find the probability that you get exactly one blue. Exactly one blue ball. Exactly one blue ball. We're selecting two. I'm selecting two. And I'm saying exactly one of them is blue. That means what? That means the other must be red. Right? One is blue means the other must be red. So if one is blue and the other is red, do I care about the order here? No. I just want one blue. Could be the first, could be the second. This in fact means this is the probability that you got blue, red, or red, blue. So it doesn't matter which one you get.
So even in the one before, I don't see that the
No.
order...
This order is, no. I said here between them, I said then. When I ask the question, I have to...
How does it matter? How does the order matter?
Select one ball. The first is blue and the second is red. It could be...
In the same case, after this, we're just multiplying.
Yeah. We here also multiplying, but here we're multiplying twice. Multiplying once for BR and another time for RB. And then I have two outcomes in this case, not just one. When I don't care about the order, then I have another case, which is the blue first or the blue second. And the event now becomes larger.
Can we give second one make blue, red, or
red, blue, yes.
Make both?
Make both. Find the probability of both. And then, after you find the probability of both, we already have most of them. Right? We already have the BR. The BR is actually what? We just 3/10, right? We got the BB also. The BB was 1/10, right? Okay, now missing what? Missing RB, which is also 3/10. So now I need both. So what do I do with both? Now I have each one is 3/10. What do I do? Add them, yes, because OR means union. So I add them. So the answer will be actually 3/10 plus 3/10, which is 6/10. So now we started looking at some of the questions require more than one outcome, and you need to have multiplication rule to calculate each outcome. And then after you calculate each outcome probability, add them. Yes?
Yes, at least one.
Very good question. This is actually was my next question. How did you know? I was going to say in the next question, at least one. Let's do it again. Okay, I have 3 red balls because just became very busy. And 2 blue. Another question is find the probability. Of course, we're selecting 2. Selecting 2. Find the probability that you got at least one red. Find the probability that you got at least one red. It doesn't mean at least one red. One or more. Very good. One or more. It's mean one red or 2 red. What is one red? RB or BR. And now 2 means R. So that means I have 3 outcomes I have to get, and then I have to add their probabilities. Because or means union, which means I get them all together. Does it make sense? So at least one in this case means I have many outcomes. Okay, I deleted the tree diagram. I can just do it again quickly. BR. I need what? I need the BB, I need the BR, and I need the RB. Do I need the RR? Which one I need? The BB? No, I don't need this. I just need these 3, right? Okay. Which was, each one of them was 3/10, remember? So all what I have to do, the answer would be 3/10, 3/10, 3/10. That would give me 9/10. Okay? Does it make sense? That's what we did last time, right? We had 3/10, 3/10, 3/10. So when you add them, you get 9/10. So as you can see, there's a lot of questions I can ask from a tree diagram like this. Yes?
The question said at most one red. It's going to be BB and RB and
Yes, exactly. If you say at most one red, which means maximum 1 or 0, which could be the first and the second and the third, which will be 7/10. If I say at most one red, it will be 7/10. If we select 3 times, then the tree diagram will look like a bit more complicated, and it's very unlikely, but it might happen, in fact, if the question wants to be challenging. So you will have blue-red, right? And then you have also blue-red. But the problem is, you have only two blue. How many blues? Two just, right? So you can't have blue again anymore. Khalas. That's it. Not possible. In this case, you already have two. So in this case, you only have red. For sure, it will be just red. There is no other option. And then you just have to fill the tree diagram and carefully check what is up. Okay? It's very unlikely. It might happen, but it will be like a challenging question. It's the same idea exactly. You want me to do it? Yeah? How many blue we said? 2? 2 over 5. 3 over 5. And this will be 1 over 4. And this will be 3 over 4. Here this will be 2 over 4, 2 over 4. Now if you take 1 over 4 blue, now there's no more blue. So it's only red. And you already, no, it's just 1. Just 1, because that's the only option. Right? It will be 3 over 3. 3 over 3, which is just 1. And you have blue, red, and then now when you reach here 3 over 4, how many? You took blue and red, so it will look like you have 3 red, right? You have 2 blue. So you took 1 blue and red, so how many? The chance of getting blue would be 1 over 3, in fact. 1 over 3, this would be 2 over 3. And this is again blue, red. Suppose that's it. Suppose the question, find the probability that you get a blue ball followed by 2 red balls. So in this case, you just multiply the blue times red, which are these probabilities, which will be 2 over 5 times 3 over 4 times 2 over 3. So that would be the case. Okay, when you simplify that, of course, this will go with this, so you just have 1 over 5. Okay? So that could be one of the, but it's very unlikely to have a question like that.
So you get the 1 of the
Which one? This?
no, but 1.
Yeah, because that's 3 out of 3. You took a blue and then took a blue, so what remain? All red. So the chance you're selecting a ball, it has to be a red. Yeah, 3 out of 3. There's no other choices. Right? There's no other choice. Yeah, but this is complicated. Don't worry much about it.